Okay, continuing along, step 3 of the Thomson experiment. You combine two equations to find the charge to mass ratio, which would be Q divided by M, which was equated to E over M, where E is the charge of an electron, M is the mass of the electron, and you get a value of 1.76 times 10 to the 11 coulombs per kilogram. All right, along came Millikan in 1913, and he discovered the charge on the electron. So if we knew the charge to mass ratio and the charge could be determined, then the mass of the electron could be found. So recall, Millikan suspended oil droplets between charged parallel plates. So when those those droplets were suspended, then the electric force and the gravitational force were equal and opposite. And if you equate the two, Fe and Fg, you come up with an equation for Q, mg divided by electric field strength, where the electric field strength is the potential difference across the plates divided by the plate separation, or delta V over D. He discovered two things. The smallest possible charge, was 1.6 times 10 to the negative 19 coulombs. He called it the elementary charge. All other oil droplet charges were multiples of the elementary charge. So Q is N times E, where E is the elementary charge. N is the number of electrons in excess or deficit. Now, if excess or deficit, you can figure that out by the actual direction of the electric force and the polarity of the plates. So Millikan believed that the elementary charge was the charge of an electron. So E was 1.6 times 10 to the negative 19 coulombs in terms of its magnitude. The mass of the electron. Combining the results of Thomson and Millikan, the mass of the electron could be determined, and that's how you get 9.1 times 10 to the negative 31 kilograms. Of course, our data sheet has 3 sig dig, so 9.11 e negative 31. All right, let's do some practice problems in a moment, okay?